Hi, I'm Rahul, and in this tutorial, we will learn about machine learning in our perspective. So, what is machine learning? Or, in other terms, people say it's AI, that is artificial intelligence. So, what is such machine learning? In generalized definition, machine learning is the field of study that gives computer the ability to learn without being explicitly programmed. That means it automatically learns from your data and also gives the predictions with higher accuracy. So, what are the different types of machine learning? First is supervised learning, unsupervised learning, semi supervised learning, and reinforced learning. So, coming to the supervised learning, the supervised learning is one in which the training data you feed to the algorithm includes the desired solutions and called labels. That means whatever the data you have the input data and the output results also, the independent variables and also the output variables x and y in both data you have available. So at that case it called supervised learning. A typical example can be a classification or a regression. In classification is mainly done when the output variable is a category, say red or blue, disease or no disease, or say yes or no. And in regression case, the output variable is a real value or say a continuous value, say dollar, weight, or speed. So coming to the one example, say a pedestrian have to cross from one edge of the road to other edge. So if the traffic is moving, then he has to find a gap that is safe and adequate so that he can cross from one edge to the other edge. And that depends on the various conditions. What is the pedestrian's age? What is the gender? What is the walking speed of that pedestrian? What kind of road he is crossing, whether it is a single lane or two lane, so what kind of gap he is accepting? Gap is basically when a vehicle pass in front of him, and then another vehicle or next vehicle passes in front of him. And the gap between this in time or in second is known as the gap. If the gap is more, then it would be easy for that pedestrian to cross from one edge to other edge or take the gap because it is quite large and safe. If the gap is or time gap is in minimum, say one vehicle crossed and after 2 seconds another vehicle also crossed in front of him or her, so at that case the gap is very small and it would be a very dangerous decision to cross or take that gap. So let's say one researchers have collected all the related variables of different pedestrians. Say what is the gender, age, walking speed, what kind of road he's crossing, whether it's a single lane road or a multi-lane road. Then what is the accepted gap? When the person accept a gap, what is the gap size in second? And approaching vehicle type. Approaching vehicle type is what type of vehicle is approaching towards him when he start as a crossing, and approaching vehicle speed and what would be the approaching vehicle speed at that time, and whether the person accepted that gap or not. So based on all these variables like gender, age, walking, road type, gap size, approaching vehicle type, and approaching vehicle speed of a particular person, whether he is accepted that gap or crossed from one edge to other edge or rejected that gap, whether he is not unable to cross. So based on this we can based on this x variables or like gender, age, walking speed, road type, we can train and we have that output variable also whether he is accepted that gap yes or no. So we have independent variables also the output variables, so we can train the model, and that model would be a supervised learning model based on the classification example. Say another example, in a hospital every patient have to take this 7 tests before he meets the doctor with this test results, and based on this test results the doctor classified that whether the person has a particular disease or not. Say every patients whatever the test they are taking, for every patient it would be different, and this different is the variance or variability in the test results. And doctor within a certain variation he can able to classify whether correctly whether he has a disease or not. But when the variation is too much, maybe the doctor won't able to classify whether he has a disease or not properly or correctly. That is the misclassification. So let's say 8 out of 10 a doctor can correctly classify whether he has a disease or not, and 20% times he is not able to classify whether he has a disease or not, and he may consult to other experienced doctor about the test results whether the patient has the disease or not. So here is the misclassification error is 20%, and 80% of times the doctor able to classify correctly whether the patient has a disease or not. So if we able to develop algorithm that can be, and we train all these test sets along with the diseases, and it able to predict a newcomer patient's such a test results based on the test results whether he has a disease or not with say 100% accuracy, it would be very fantastic to develop certain algorithms that will classify or that will classify the disease with 95% or 100% accuracy. So that actually the machine learning algorithms actually do, and the researchers and scientists basically improving those algorithms so that the misclassification error gets lower and lower over the course of time, and the accuracy get increased. Say in near future we'll get 100% accuracy in classifications. So this is one of the example for supervised learning, because we have the test results along with we have the classification of whether the person based on this test results having a disease or not. So coming to the regression example, based on the continuous data, say we have data set over past 1 year of a particular land, how the land price is fluctuating over the course of time. And if we train with these two variables, price and the time, we can easily identify at a particular time what would be the price based on the supervised learning algorithms or supervised learning models. So type of supervised learning methods. There are various methods available. These are the popular ones: linear regression, logistic regression, k-nearest neighbors, naive Bayes classifier, and support vector machines, decision tree, and random forest. Random forest basically ensemble learners comes under ensemble learner category, and neural networks, which is quite popular nowadays for deep learning purpose. Coming to the unsupervised learning. These are called unsupervised learning because unlike supervised learning, there is no correct answer or labels or say teacher. There is no teacher. Let's say we have I'm a owner of a particular company or say online store, and I want to classify my customers based on their purchasing behavior. So how would I classify? Because I don't have any idea how it would be classified. I don't have the output variables or y labels. So there are fewer algorithms, different algorithms are available. Based on that, we can classify those customers. Say based on, there are two types or many types of classification or unsupervised learning models available. The popular ones are clustering. A clustering problem is where you want to discover the inherent grouping in the data. Say you want to divide the customers based on their purchasing behavior into different groups. And another is association. An association rule learning problem is where you want to identify rules that describe large proportion data, large portion data. Say a physical or online store where association algorithm basically used to identify the purchasing behavior of consumers. Whether a person buying X would also buy a Y. What is the probability? You can also identify based on the purchasing frequent purchasing behavior, and also you can identify the sequence in which they buy the objects or products. So that would be beneficial for a say store or online store to identify and showing similar kind of ads to a person who is purchasing one thing and also tend to buy purchasing other thing. So type of unsupervised learning. These are the populars like clustering. In clustering, K-means clustering, hierarchical clustering, density-based clustering, and model-based clustering. And in visualization and dimensionality reductions like principal component analysis is quite popular. Kernel PCA, linear, locally linear embedding, T-distributed stochastic neighboring embedding, and association rules to identify the frequent objects and sequence mining. It is usually basically used for data mining purpose, like a priori and eclat are the popular algorithms. Coming to the semi-supervised learning. In semi-supervised learning problems where you have large amount of input data X, and only some of the data is labeled Y, or output data you have only few data has labels or category, and some are say missing, are called, in this case it called semi-supervised learning problem. Most semi-supervised learning problems are a combination of supervised learning and unsupervised learning. The semi-supervised learning examples like web page classification, in which certain data is given to the model that whether a particular site is a education, shopping, forum, or say blog site, or a social media site. So it has limited data on labels. So over the course of time, it learns that what would be the characteristics of that website, so that it can be classified as educational, shopping, or say particular social media site. And over the course of time, it learns and improves the predictions or improve the classifications. So next is reinforced learning. In this learning system, when model predicts a features or outcome correctly, it gets a reward, and when it predicts incorrectly, gets a penalty. For example, in children, if your children gets a high mark in your high school exam, then you probably give a reward like uh, giving a party, giving a cell phone, a new cell phone to him, or giving a chocolate, or giving a or going with your children to a holiday. But if this is act as a reward, and if he won't get a good mark, then he won't get all this kind of stuff. That would be a penalty. So similar in learning algorithms, uh, the researchers also use the same analogy, like if the algorithm predicts the output correctly, then it gets a reward, and if it is not able to get the correct results or predicts incorrectly, get a penalty. When it get rewards, it automatically identifies based on what features it get rewards, and improve those features to improve the algorithm, so the learning process get improved. Like the robot, basically when a robot learns how to talk or how to walk, it automatically, when it when it falls down, so it get penalty, and if it not falls, then it get reward. At that case, the robot automatically algorithms such as learns that at what condition I'm not falling. So from that, it automatically learn to walk over the course of time, when it improves its such a learning and algorithms. Like Google's AlphaGo, it also is based on this reinforced learning analogy or method. The Google Assistant in mobile phones, it automatically learns from user behavior or user queries. Like Google's AlphaGo AI beats world's best human Go player. This is also based on the reinforcement learning, where the Google AI teams train that particular model or particular algorithm how to play a Go game, and how to correctly predict the future moves, so that it its probability of winning get increased. So this is basically the AI or machine learning. And in this our tutorials, we will go step by step, starting from the supervised learning like regression, logistic regression, and one by one we will go towards the unsupervised learning. So thanks for watching.